Imagine like a world where traffic jams are like a thing of the past, and robots can predict accidents before they even happen. Host speaker. That's the kind of future that quantum computing is like pointing towards by like totally changing how we solve those super complex problems. Host speaker. And today we're doing a deep dive into this one really cool piece of the puzzle, this research paper we found. It's about how quantum computers can learn how to play Connect 4. Host speaker. I know. You're probably thinking Connect 4, seriously. But trust me on this game, it's like a key to unlocking some really, really big concepts. Host speaker. So like, stay with us here. Expert speaker.
Yeah, this research, it's not about creating some Connect 4 master. It's about exploring quantum reinforcement learning, Host speaker. Okay, yeah, let's write that down. We talked about reinforcement learning before. It's basically like teaching a dog a new trick, right? Or like rewards and stuff.
Expert speaker. Yeah, exactly. But instead of treats, we're talking about algorithms. Those are basically like sets of instructions for computers. They learn through trial and error using a ton of data. Host speaker. Got it. So then like, where does the whole quantum part come in? How does a quantum computer learn differently? Expert speaker. Okay, so that's where things get really wild. A regular computer, it explores possibilities one at a time, like walking every path in a maze until it finds the right one. But quantum computers, they can explore multiple paths at the same time. It's like they just know the best solution way faster. Host speaker. Whoa, so in this Connect 4 research, the computer wasn't stuck just looking at one move at a time. Expert speaker, exactly. They used this method called quantum tagged action selection. Sounds super complicated, but just imagine the computer looking at every possible move on the Connect 4 board all at once, weighing the outcomes for each one, and then deciding. That's the kind of power we're talking about. Host speaker. Wow, that's incredible. Okay, so they basically gave this quantum computer a crash course in Connect 4 using this, like, see the future ability. What happened? Did it turn into some strategic mastermind? Expert speaker. Well, it didn't become a world champ or anything, but the results were definitely promising. The researchers found that the quantum approach, it was way more efficient at learning compared to the traditional ways. Host speaker. More efficient. Like how much more? Expert speaker. The quantum model got a 20% higher win rate after just 50 games compared to the regular model. That's a huge jump. Host speaker. Wow, 20% is huge. So even though we're not all going to be challenged to Quantum Connect 4 anytime soon, these findings still seem super important. Expert speaker. Right. Exactly. It's important to remember that quantum computing is still super young. This research is like a little peek into the future, like a hint of what might be possible as this technology gets more advanced. Host speaker. So no Quantum Connect 4 showdowns for us anytime soon. Got it. But these findings, they have implications beyond just games, right? Like this could be huge for other stuff too. Expert speaker. Oh, absolutely. If we can use this to make better decisions in a simple game like Connect 4, imagine what we can do with way more complex problems in medicine, finance, maybe even understanding the human brain one day. Host speaker. Okay, now that's what I'm talking about. But before we get too ahead of ourselves, let's zoom in on the specifics here. What's it actually like to build these quantum algorithms? Can't be easy, right, expert speaker?
Oh, you're totally right. There are definitely some unique hurdles that researchers are dealing with, yeah?
Yeah, it's true. Quantum computing has its challenges. Trying to write a symphony, but for an orchestra full of instruments we don't even know how to play yet.
Okay, I like that. So what are some of the instruments in this quantum orchestra that are giving us trouble?
One of the big ones is just how complex it is to design these quantum algorithms. The way we program regular computers, it just doesn't translate to the quantum world. It's almost like trying to explain colors to someone who's only ever seen black and white.
So we need completely new ways of thinking, new tools, new everything to even start to use this technology.
Yeah, pretty much. And then there's the problem of noise and errors, which are a much bigger deal in the quantum realm.
Noise. Like a loud room, making it hard to think.
Exactly. Quantum computers are crazy sensitive. Even the smallest change in temperature or vibrations can mess up their calculations. Imagine trying to build a house of cards in a windstorm. It's kind of like that.
So we've got these super complex, super sensitive systems, and we're asking them to solve problems our best computers can't even handle. Sounds kind of risky.
It's a huge challenge, for sure. But researchers are making progress. They're developing these error correction methods to deal with the noise, like algorithms that can basically self-correct when there's interference. And the quantum computers themselves are getting more robust, too.
So it's like we're reinforcing that house of cards, making it stronger so the wind doesn't wreck it?
Exactly. It's constant improvement and refinement. And the amazing part is, even with all this, we're already seeing how powerful quantum computing can be.
It's like those early explorers heading into the unknown, The journey is just as important as where they end up. Speaking of the journey, we've been in the technical weeds for a bit. What could quantum reinforcement learning actually do? Like real-world stuff?
The possibilities are huge. We talked about robotics, self-driving cars. Imagine robots that learn from their experiences in real time, or cars that can navigate traffic like a person could.
So we're talking about machines that don't just follow orders, but can actually learn and decide things on their own. Like really learn.
Exactly. And it goes way beyond that. Healthcare, for example. Quantum algorithms could analyze tons of medical images to catch diseases super early or create personalized treatments. Things we can only dream of now.
Or in finance. Trading
Yeah.
in the stock market, that kind of thing. We've all seen those movies.
It's not sci-fi anymore. The possibilities are huge. Entirely new industries could be built on this.
I gotta admit, this is pretty exciting stuff. But we have to remember, with any new tech, there are downsides too, right? What are some ethical things we need to think about?
That's super important. Quantum computing is a powerful tool, and any tool can be misused. We have to be really careful about how it's developed and used.
Like we talked about medicine and finance. But those could be misused, right? And lead to new problems we haven't even thought of.
For sure, and there's the whole issue of jobs. As quantum computers get smarter, they could automate jobs that people do now.
It's a double-edged sword. It could solve our biggest problems, but also create new ones that we aren't ready for.
Which is why it's so important to talk about this now, while it's still early. We need rules and ethics to make sure quantum computing is used for good.
It's a lot to process. Every time we learn something new about quantum computing, it's like 10 more questions pop up.
Yeah.
But that's what happens when you make groundbreaking discoveries, right? It's kind of weird to think about like the downsides of something that's barely even here yet, like worrying about the traffic laws on a planet we haven't even found. But you're right, we got to think about this stuff.
Yeah, definitely. One big concern is, well, people using it for the wrong reasons. Like, quantum computers could be used to break the encryption that protects, all our online data, our bank info, everything.
Okay, now that is a scary thought.
Right. It would be like giving someone the keys to Fort Knox, except Fort Knox is like all our digital lives.
Yeah, basically.
And then there's the possibility of using them for autonomous weapons, Weapons that could decide who lives or dies without a human being involved at all.
That takes things to a whole other level.
Right. It's like giving a gun the ability to think for itself. These are really serious things we got to figure out, like, now, before this technology gets any more powerful.
It's a lot to think about. Feels like every time we learn something new about this quantum stuff, it's like 10 more questions pop up.
Exactly. And that's what makes it so fascinating, right?
Totally. It reminds me of what we were talking about earlier, that it's not just about the destination, it's about the journey.
Yeah, for sure. It shows that we're always pushing the limits of what we know.
Yeah.
And every time we take a step forward, there's a whole new set of, responsibilities that come with it.
Well said.
Mm-hmm.
So, to recap this whole deep dive on quantum reinforcement learning, we started with what seemed like a simple question. Can a quantum computer learn to play Connect 4? And it kind of spiraled from there.
And that simple question, it opened up this whole universe of possibilities. We talked about how quantum computers learn, how they can explore so many things at once, and how that could totally change everything. Medicine, finance, maybe even how we understand intelligence itself.
This whole thing has been a wild ride. But the thing that stuck with me is we're right on the edge of something totally new. A whole new era of computers and technology that could change the world in ways we can't even imagine yet.
Totally. And as we move into this unknown territory, we got to be careful. Curious, but cautious. Excited, but a little skeptical, too.
Well put. To everyone listening, think about this. What are you going to deep dive into today? And how are you going to use that knowledge to shape the future?